see the hyperconjugation, student. We are going to understand hyperconjugation, right? When a CH bond is attached to unsaturated system, so CH bond is attached to unsaturated system, student. So this is the unsaturated system, and here CH bond is attached here. So what the such a double bond or a benzene ring, the sigma electrons of the CH bond interact or enter into the partial conjugation with the unsaturated system. So this one is partial, it is going to be attached with the no, that is conjugation with unsaturated system. Now see, the interaction between the electrons of pi system, that is multiple bond, and the adjacent sigma bond, no, adjacent sigma bond, single CH bond of the substituent group. So this group is what? This is the substituent group, and this sigma bond they are talking about in an organic compound is called hyperconjugation. Okay, so this electron is going to be in the conjugation with the pi system. The concept of hyperconjugation was developed by the Baker and Norton. So that this is also, this effect is known as Baker and Norton effect. Now go for the another point. What is the other point, student? So here you see, according to this concept of an alkyl group carrying at least one hydrogen atom, attached to a unsaturated carbon atom, it releases electron of carbon hydrogen bond. Towards the multiple one. For example, the hyperconjugation in propene is shown as. Okay, so let's see the hyperconjugating structure. So this is what, student? That is the propene. So here pi bond is going here and sigma bond is coming. So here you will find there is no bond, student. So that is why up now this bond is shifting here, right? So here you will find that is no bond. If this bond is shifting here, no bond. So they are the conjugation, that is sigma bond is getting in the conjugation. They are saying the various hyperconjugation forms of propene are called contributing structure or the hyperconjugative structure. In fact, hyperconjugation effect is similar to resonance effect. This is similar to resonance effect. Since there is no bond between the alpha carbon atom and one of the hydrogen atom, the hyperconjugation effect is called no bond resonance. So here you can see, because in this case, where is the bond? You will find there is no bond, student, right? Here is the bond is not there. This way you can see, this way you can see, this way no bond. So that is why no bond resonance. However, it may be noted that although a free proton has been shown in the above structure, it is still bound quite firmly to the pi cloud, and hence it is not free to move. Now let us go in the next statement. It is clear from the above structure that hyperconjugation occurs through the hydrogen atom present in the carbon atom next to the double bond alpha hydrogen atom. Okay, so see, this one is going to be double bond, they are double bond, so this is going to be alpha carbon, so they are the alpha hydrogen, that is the alpha hydrogen. Therefore more the number of alpha hydrogen atom, more are the number of hyperconjugative structure, thus hyperconjugation effect is expected to be more due to CH3, that is methyl group, than due to the CH3CH2 ethyl group, because of the latter has only H atom attached to the alpha carbon atom. In a similar manner, the hyperconjugation effect will be less if CH2 twice CH is isopropyl group is attached to the unsaturated system, and therefore will be no hyperconjugating structure. Okay, so now the point which we have to understand here, that is a very important point. Okay, let us try to explain, student. They are saying more the number of alpha hydrogen, more will be but the hyperconjugating structure. Thus, hyperconjugation effect is expected to be more due to CH3 methyl group than the due to the CH3 CH2 group, because this is not the alpha beta carbon is there ethyl group, because the latter has only two H atom attached to the alpha carbon atom. In a similar manner, the hyperconjugative structure will be less CH2CH isopropyl group attached to the unsaturated system, and there will be no hyperconjugation effect, okay, in this one tertiary butyl group, okay. So thus order of hyperconjugation: CH3 CH3 CH2 CH3 twice CH and CH3 thrice C. Orbital concept of hyperconjugation. The orbital concept of hyperconjugation may be explained with the help of the propene in the electron pair of the CH bond. It is involved in the conjugation with the pi electron pair of the double bond. Therefore, hyperconjugation involves delocalization of sigma electron of CH bond through the overlapping of p orbitals of the double bond as shown. So this is the hyperconjugation unsaturated system, and here is the CH bond. No, this is now. Hyperconjugation is also possible in organic compound is positively charged carbon atom which has an empty p orbital. So positive charge is there, this is the empty p orbital. To understand this, let us consider the CH3 CH2 ethyl carbocation. One of the CH bond of the partial methyl group can be aligned in plane of the empty p orbital, and the electron constituting the CH bond in plane with this p orbital can then be delocalized into the empty p orbital. Therefore, in this case, hyperconjugation arises due to the partial overlap of sp3 s CH bond with the empty p orbital of an adjacent positively charged. So this CH bond electron is shifting here. So as a result, they are going to involve in the no bond resonance, students. Right. So this electron is shifting here. So this will not be any bond here. Wherever the positive charge is there, then here is no bond. Then it is no bond is here. They are not showing. So this type of overlap stabilizes the cation because of the electron density from the adjacent sigma bond help in the disappearing of the positive charge. Thus, in the general, larger the number of alkyl group attached to the positively charged carbon atom, greater is the hyperconjugating interaction, and consequently greater the stabilization of cation. Thus, the stability of carbocation is what is there 3 degree, 2 degree, 1 degree, and then methyl carbocation. Application of hyperconjugating structure. Shortening the carbon-carbon single bond adjacent to multiple bond. In the presence of carbon-carbon bond adjacent to double bond, acquires some double bond character, and hence it is little shorter. Next one. Stability of methylated alkenes. Okay. Larger the number of methyl group linked to the carbon-carbon double bond, more is the number of hyperconjugating structures, greater will be stability of the alkene. Okay. So this is what is the applications of the hyperconjugating structure, student. Thank you so much for watching.